thank you very much for inviting me here. Okay, it's forward. And it's a real pleasure to be involved in such a professional, well-organized conference at a time when we really must change the construction industry as fast as possible in pretty well all countries. I'm going to run through lots of ideas very quickly. Z Factory stands for Zero Fossil Energy Developments, which is producing a world that no longer relies on fossil fuel. And we called Factory because we collaborate with industry to create products and services which make it easier for this industrial transformation. And we see this as two things. It's changing the way we live, changing the way we work, designing new forms of human habitation. So we produce these kind of diagrams to design lifestyles and to design work styles, to try and show how a step change reduction in carbon footprint can be reconciled with an increase in overall quality of life. And this is nearly always possible. And the countries that are most addicted to fossil fuel and high technologies will be least prepared in the coming century, because there's a massive problem with dwindling global resources. Now, the traditional idea is that you can't afford to change an industry. You can't afford to go green. You can, but you can only achieve it with volume. So the way the industry has to change is it has to have very small projects that show what is possible. Gradually, economies of scale, industrial production makes them more affordable. And then once you get above about 5,000 units, whether it's homes, workspaces, renovations a year, you start to find that going a low-carbon construction industry becomes more affordable. And I'm going to quickly show some of our previous projects and try to share some ideas on how a developing green construction industry can actually create a more desirable product than business as usual. And this is how we have to win the argument. We have to show that people will want to buy, live in, work in this new world because it's better, not because they want to save carbon, because they want to save money, because it's more fashionable, because it's sexier, because it's just generally a more preferable, intelligent choice. So this concept we call in our office enlightened self-interest. So the idea is, can you put human habitation in a landscape at the same time as preserving the natural world, or preserving natural capital? And BedZ is an example of a living, working community. It's not a housing project, it's not an office project. It's a mixture, going back to the medieval concept of living and working in the same place. But here, we've put gardens on top of workspace roofs. And we've achieved an overall net increase in density, which has funded the additional construction costs of the low-carbon specification. At the same time, this produces a new urban morphology. So it's matching economics with politics, with overall low-carbon targets, but also looking at behavioral change and reconciling these new ideas, bringing technology together. And the big thing that made this possible was because the local government gave themselves permission to build the scheme at the bottom of this slide, and we built the scheme above, and that created overall about a 35% increase in floor area. We didn't have to that compared to that created a saving in the development appraisal, and that created the funds to produce a low-carbon demonstration project. And we call this carbon trading in return for planning gain. So if it's possible to reconcile, to integrate low-carbon transportation, energy-efficient buildings, energy-efficient workplace, and plug it into the existing city, you can get very spectacular results, far more spectacular than if you just concentrate on buildings or master planning alone. So this is a view from the air of BedZ today. These are just images showing what priorities we used in designing this new urban fabric. This is looking at sunlight falling on gardens, and the sky gardens at BedZ have more or less the same number of sun hours as a south-facing garden with a 2-metre high perimeter fence, which is the prevailing urban condition in the UK. Now this is important because if you can offer everybody a garden, people will want to live in this place. People will want to work in this place. Why should you work in an office? Why wouldn't you rather work in a garden? Now, this is important because as climate change accelerates, it's going to be more and more important to have both indoor and outdoor living and working. So it's this relationship, this connection to the landscape. We don't want to look through lots of layers of energy-efficient glass. We want to be part and experience the wind in our faces, the sunlight coming in, fresh air, and above all, appreciate other life forms, plants, animals. So it's this connection with nature which is lost in a lot of green buildings, which hermetically seal the environment. So at BedZ, we consider this as a landscape. It's an inhabited piece of landscape. It's not a piece of architecture. It's not a piece of urban design. Now that's what creates the added value. Not necessarily the low carbon technology, not necessarily the super insulation, not necessarily the lower carbon footprint. It's the fact that you have a garden and you have sunlight coming into your home. And there are lots of things that we can do better. There's lots of areas where it can be improved. This is relatively low-cost housing. This is a 1/3 social rent, 1/3 shared ownership, 1/3 private for sale. But the thing that really stands out, and the reason why it's popular, is that families and indeed workers are given an outdoor space where previously they would have had nothing more than a flat balcony. These roof gardens have 300 millimetres of soil, 300 millimetres of insulation, and then very high levels of thermal mass. And some of the ideas that we integrated into BedZ, like the building integrated photovoltaics, the sedum roofs, these are passive heat recovery ventilators, little silver discs blow open in high winds to stop over ventilation. The roof lights provide cool north light to the workspaces so that you don't have to spend a lot of money on expensive shading systems. And we spend a lot of time working on the public open spaces so that you have the same feel, secure urban design, and you have places that communities want to meet, congregate, and live in for very long periods of time. We celebrated 10 years of BedZ last year, and the first BedZ baby actually introduced the event. So you can tell how successful a community is by how frequently it reproduces itself. So what's the point about this? The point about this is it's not about technology. This is about architecture. This is about passive engineering. This is about energy efficiency. And it's about a new urban language. And it's about respecting climate and using all of these ideas to minimize the need for energy to the point where it could be met by renewable energy sources. So we're designing nothing more than a super insulated, sunny cave with heat recovery ventilation. Well, I know there's a lot of really good cave dwellings in Turkey. I don't know there's very many cave offices, but perhaps there should be. But the story about BedZ is people come to look at the technology. There really isn't any. And when we did fit technology, it broke down very quickly. So my advice is stay clear of it. It's one of the things where if you can minimize technology, you'll have the most resilient systems. Just about the only piece of technology worth talking about at BedZ is a biofueled combined heat and power plant, which ran very well for the first year and a half or 2 years of operation, and then completely broke, and we couldn't afford to replace it. So Even though today it's running on a little, very small condensing gas boilers, it uses so little fossil fuel to run the development that it's still a great low carbon success. But most important of all is the language and the fun, because green buildings have not been much fun to date. Can you capture the public's imagination? This is a live-work unit. There's a kitchen in a cupboard for people who don't like washing up. There's a bed deck above. These are very popular with young people starting new businesses. We built a bar in our offices. We designed it so that shade zones to the north of the housing could be subdivided into very small units, encouraging micro businesses, or opened up to very large companies, perhaps employing 50 to 100 people and taking a whole terrace. So this idea of long life, loose fit. And then the idea that gradually it would become, the people would forget about the buildings, it would just become overgrown. We've raked back the elevations to make sure that sunlight, which gives very useful passive solar gain in the winter, so much so that with the super insulation, you don't actually need a heating system in the houses, providing you cook yourself a meal. Now this is important because if you take the building physics model that was used to design BedZ, and you applied it to the rest of British housing, then you wouldn't produce the kind of homes that you see immediately over the fence, which is the alternative, which is what would have been built on this site if BedZ had been, it hadn't happened. So there's a lot of, my plea is really to give these demonstration best practice projects a chance. And it can work financially. There's pretty well, we've never, on the private for sale units, we've always achieved a 15% sales premium compared to the existing properties around, immediately over the fence. And this has been demonstrated time after time. So 10, 12 years later, the project isn't perfect, but it really is starting to demonstrate that it's a relatively low risk to engage in these particular balance of technologies and urban morphology. Then the next idea is how do we crank up, and where do we go to really look at the future? How do we give the farmers a market? How do we resist urbanization? Why do we all need to live in cities? The answer is we don't. We need to give farmers more money. We need to give them a higher quality of life. We need to give them income. So we've been designing the urban metabolism around what's called a zero fossil energy farm, where you produce food using renewable energy, organic food, you reclaim nutrients from urban and rural environment, you produce food without packaging, and you distribute food without using fossil fuels. So these are big ideas, and we've been working hard on this for a period of years with farmers, and this has produced some of these technologies that we started when we did BedZ have really now matured. And this is what's interesting. How does technological progression change architecture or change urban design? This is the combined heat and power plant at BedZ with a living machine. Both of these technologies are currently not working for various reasons, mainly economic. We weren't allowed to the living machine, the grey and black water treatment plant, had to require a man in a white coat from the government, from the Ministry of Environment. He had to come and produce laboratory tests every day because they didn't trust the community to manage their own local facilities. This was not required, this was unnecessary, but this was centralized government responding and biting back to local initiatives. And that's what the Turkish Green Building Council has to jealously defend and protect and promote. So integrating farmland, but one of the things we found at BedZ that really could work well was this idea of working with the surrounding farmland, using waste, agricultural waste, and perhaps using organic waste from the city without competing with food production. So the red on this diagram produces straw. This is urban waste. You do all your recycling as part of a zero waste urban system. And if you heat the organic material without oxygen, then you get very hydrogen-rich biomethane, which can then be put cleaned and scrubbed and put into the city gas grid, and you can get large city centre projects paying for pyrolysis units out in surrounding farmland, and we call this hydrogen farming. And this is interesting because the byproduct of this process is pure carbon, pure charcoal, and that can be sequestered, that can be buried as a soil fertilizer, biochar soil restoration. And that takes about 20% of the carbon in the biomass out of the carbon cycle. So it's the only technology we know that actually starts to clean the sky, reduce overall climatic CO2 levels. And you can liquefy the gas and produce liquefied biogas, and you can then use that to run transportation systems as a replacement to LPG. So I'd like to see the taxis in Istanbul working on liquefied biogas within the next 5 years. So this idea of the city as a metabolism is also complemented by the idea of the ingredients of the city being actually starting to microgenerate. And if you worked out that the farming system and the urban and the organic material produced by a city could perhaps contribute about 40% of the overall energy needs in a fuel-efficient city, then 60% can easily be met by building integrated renewable energy. And the thing that worked really well at BZ was the photovoltaics. Nothing moves. They were built into glass, they were sealed into the building, and they just quietly get on with their job of generating electricity year after year. And so we thought, well, people are making solar panels. Well, how do you make solar panels more cost effective? You make it part of the roofing system so you don't have to buy a roof. And then you don't have to build solar farms because actually that's stupid. You're losing valuable agricultural land. We're running out of natural capital as it is. Raise the solar farms up in the air and you can house over your industrial estates or your roads or your parking areas or your markets. You can then collect water, condensate from underside the solar panels. If you cleverly design them, you can collect rainwater from them. You can create covered markets, large-scale communal solar arrays. And that starts to set up the city of the future. That starts to set up the ingredients. And we're currently in production with these technologies at the moment. And we're starting to get the first large community-scale solar markets being built, mainly in China at the moment. But some of those are coming to the UK. So it's this understanding of what technology you use where, is most important, because normally this is what people get wrong, this is what politicians get wrong, it's what green building councils get wrong. They get bogged down in whether the solar industry lobby them for the only solution is photovoltaics, the solar thermal people say the only solution is solar hot water, the biomass people lobby the only solution is biomass, CHP or wood pellets, and so on and so forth. It's tedious. Actually, they're all required. Everybody has their place in this low carbon society. You just have to work out which technology is the right thing to do in the right place. And we've been working on a very simple mathematical formula which we think actually replaces a lot of the work done, particularly the lead systems, which basically looks at balances embodied carbon, the energy required to maintain a building, the actual energy used by the building, the durability, and then we divide that, and also the amount of renewable energy that a building generates, but when we divide that by the energy invested in the construction of the building in the first place, and we get a very simple equation, which is the number of years to carbon payback. And this gives you one figure, one single figure. It's like if you could distill all of the green construction standards into one number, which is the number of years until carbon payback, then you can immediately, it's a fantastic bullshit detector. You can't cheat this. It is mathematics, it's building physics, it can be monitored, it can be checked. It's a great leveler. And it stops the industry from vast amounts of money. It's like a tax. You hire an expensive consultant to try and give you the cheapest way of achieving the maximum LEED score or the maximum BREEAM score. but you're not actually making any difference to global carbon footprint. You're not actually really helping very much. So this is my plea: simplicity, honesty, and a very simple mathematical formula. And I'll be very happy to share that with anyone who's interested. And we've been working in the UK now, trying to show how we can change our industry by introducing zero energy bills homes. And by using the roof integrated photovoltaics, we create a concept called the solar loft. If you design master plans with 2/3 of the solar panels, 2/3 of the roof surfaces facing south, you generate far more electricity than you can use in a year. With a modest feed-in tariff, UK has one, Turkey has one, you suddenly find that you're in about a 3 to 5 year payback on top of the cost of fitting an additional roof, so the payback is very short. And if you develop some standard house types with fixed costs and then a design code which enables large master plans to accept different housing typologies, you can then launch that to the consumer, and that's the big experiment that we're doing this year. And we're really showing the government and the existing house builders how they could move to this step change reduction. These are energy positive homes. They generate far more electricity than they use over a year. And we're able to sell these directly to the general public by working with landowners and selling plots with kits. And there's a whole range of self-build mortgages, so you have to work with a self-build mortgage provider, and that produces this kind of community. I appreciate it may be low density for Turkey, but 70% of the homes in the UK are built at 50 homes per hectare or under. So this is what we're doing at the moment, and we're finding that the public is really interested in this concept, because the typical energy bill in a UK home is around about £1,500 a year. If you're able to offer them no net energy bills at all, then that's £1,500 saving, and then they can clearly see that over the life of a building, this will make a very big difference to the family economy, or indeed the economy of a business. And so this is a graph showing energy production versus demand. Red is the demand, black is the production, and you can start to see how the overproduction in the summer and importing of energy in the winter, and that fits very well into a smart grid system. But overall, the cash flow is very positive. So instead of apologising for the additional cost of low-carbon buildings, actually, we're selling it to the public because actually they'd be really stupid if they didn't buy one. They're actually locking themselves into a very precarious future with an annual fuel price escalator in the UK of somewhere between 8 and 10% a year for the next 5 or 6 years. Then we start to create jobs, employment, green jobs, creating these kind of homes. We start to go into mass production, start to generate, working with industry, incorporating thermal mass into dry construction techniques for passive cooling. Looking at advanced computer-controlled milling operations, reducing the embodied carbon of foundations using GGBS-driven mini-piles, starting to raise the buildings up so that they can cope with flooding. I nearly didn't come to this event because my home was very nearly flooded. And that produces villages like this. It produces villages and workshops with factories and jobs, and you start to get a virtuous circle where the community can understand how moving across to a low-carbon economy actually creates a more attractive future. And then you can scale up these concepts. Here we're working at larger scales. This is now up to around about 100, 120 homes per hectare. And this is examples of the same concepts, but applied in the centre of Shanghai. This is the urban best practice demonstration area for the Shanghai Expo in 2010. So we're looking at how we can do living, working communities to replace the Chinese preference for very high-rise buildings with very low levels of low overall density levels, because they surround them by roads and underused parks. So I wanted to show how some of these ideas join together, and if you involve behavioural change, you can get spectacular results. This is apartments by the sea in Brighton. Unfortunately, they were 3 times higher. They got lopped off by local residents complaining about the height of these towers. So they're rather short now, but the concept works well because however many floors you put on this, you can always generate enough renewable energy to achieve a zero bills apartment at each lift of the design. Has an undercroft with doing all the sort of normal urban active frontage, cafes, all the lifestyle things that make integrate a building within the city successfully. But starting to look now at climate change adaptation, starting to look now at flooding, surface water, starting to look at how the building blocks could change, store rainwater better. How would it change rising sea levels? Because there's going to be quite a policy of planned abandonment on the UK coastline. And so we designed a parking undercroft which could be abandoned over the lifetime of the building. So probably by 2080, very substantial changes would start to occur. And this is all happening very fast, minimizing overheating. As we're failing on climate change mitigation, climate change adaptation becomes absolutely critical, and that's very much the mood in the UK at the moment. The country very battered by the weather over the past. We've been on flood alerts since Christmas Eve. So this idea about not necessarily building, but designing inhabited landscape, I think is helpful to the green building scene. This shows how the same principles, being able to walk from the street up to a sky garden, maybe it's 15, 17 stories in the air, but the idea that the park is integrated within the housing we're building this. These are communities about 2,500 homes in Dalian in North China. But what it does is it shows that where there's bravery and a desire to look at different urban morphologies, there is hope, because if we hadn't done this, there would have just been rows and rows and rows of standard high-rise buildings. I wanted to quickly show two last ideas. One is that as the winds grow stronger, as there are more and more refugees, as Turkey has problems with resettlement of refugees from Syria, we've been looking at how to cope and how to do zero bills communities or zero carbon communities with people who have very little. And almost the less people have, it almost becomes easier. So we've been looking at how we can create permanent settlements instead of providing tents that form part of a future city that's been planned around the principles of a zero carbon, zero waste future environment, complete with a market, mosque, hospital, agricultural system. And the accusation that we can't afford to change and introduce these ideas into new settlements is ridiculous, because actually we're doing it in Africa on budgets of 1,500 euros per bed space. So and that's possible. It's not even it's not a fantastic challenge, although obviously some of the space standards and some of the internal finishes would have to be changed for a more affluent society such as Turkey. But the point is, when you have nothing and you have no infrastructure, it really makes sense. And you can create these kind of environments that work well. You can create earth shelter structures that dramatically reduce the need for air conditioning. You can use local labour to build them. And you can go a lot further than traditional aid organisations will tell you. It only costs 3 tents to provide permanent cities for the future, which can take densification and expansion. And what this has been teaching us is that if you think through these challenges and you start to plan how you provide water, sanitation, if you think through security, because at the moment many of these places have people on pickup trucks running through with machine guns, terrorizing the community. If you think through all these things, it is possible to provide a workable future. And what we found then was that there was no chance of power stations. There's no fossil fuels often available. We had to power everything from one simple technology, which is a solar marketplace, communal solar array. And we've been charging very small batteries, portable batteries, which can be charged from solar for each home, but also run LED lighting strips, but also run electric personal transportation systems. And the savings on carbon footprint from integrating personal electric transportation is spectacular. And we've been trying these ideas now for nearly 10 years. No, sorry, not more than 10 years, 20 years. Built our house 20 years ago. My long-suffering wife, Sue, we've really tried to show that these ideas are starting to be workable. And if you say in Istanbul today that there is just traffic everywhere, there's quite a lot of air pollution from fossil fuels, this is the kind of future that you could be looking forward to. Very low-cost electric vehicles, perhaps made by local workshops. All the technology is perhaps only in the wheels and the electronics. And perhaps covered markets, and perhaps all the large areas of tarmac and flat roofs can be converted to these kind of solar power stations. And what we're finding is this really works. This is far cheaper than engaging in the expensive infrastructure of fossil fuel power stations and distribution. And we're marketing this thing as something called a Z Street, where you actually use the street to provide the water, water treatment, water supply, cooling. We've got ice cooling systems that are powered by solar energy. They're in shipping containers which can be integrated within the architecture or turned into the streetscape. And these things make so much more sense than relying on conventional utilities. And finally, I've gone on too long, we're renovating this existing buildings, all these technologies now being applied to an existing building in Holland, working with the WWF One Planet Business Garden team in Amersfoort. And I just want to show how pretty well everything can be used to turn a very bad existing building into a really fun low carbon or zero carbon demonstration project. And this is an example of understanding the carbon implications of every single design decision, measuring it, and then making sure that you integrate enough renewable energy systems to actually power the new use. So we put a climate shell made from the photovoltaic roofing system over the whole building. We then made all the horizontal roof surfaces into gardens. We connected all the gardens up with ramps, stairs, and walkways, and you get this. You then suddenly get a very dull tax collector's office building turned into a garden. So it's a business garden. You work in a garden. And I think this is the future. We don't have to knock buildings down. We can convert what we have, but urban design and cityscape will change. I think that's my main lesson really is if we can do this now because we've got the economies of scale, the industrial design of the individual components, the prices have dropped enough. It now becomes more economic to do this than to refurbish it using conventional passive house techniques and build power stations to serve it. And so this combination of passive energy efficiency and renewable energy and imaginative architecture is the way that we'll power ourselves into this new future. Thank you.